Okay, so let's kind of tie all this in together now. And we're going to talk about local extreme values. So that's basically what we've kind of been doing, although we haven't really given it a specific name yet. So what we're going to say is we're going to have some interior point. All right, so if we've got a graph, some sort of graph situation where we've got some stuff going on, and it looks like that. Then what we're talking about is if we're some interior point on the domain. In other words, we're somewhere in a domain from A to B. Okay, somewhere in here. All right. There's some specific point. Okay, where we're going to have a local maximum if other points are less than that. Okay, in other words, if our y value reaches a certain height and doesn't go past that height on our interval, we have a maximum value. Okay, same thing for a minimum. We're going to have a specific minimum value if at that specific point there's no values less than that. So then we're talking about just things that are y values that are a larger number. Okay, so a function has a local max or a local min at an endpoint. Okay, at an endpoint if it's included, if the interval includes that specific endpoint. So some half-open domain interval. So what are we talking about? We're talking about like half-open might like be here's an open, here's a closed, and that's a half-open interval. Okay, we can take this guy right here. Okay, we include this one. We don't include this one. Okay, because we can't actually get to the endpoint if we're open. All right. So the local extreme value theorem then says if a function f has a local max or a local min at an interior point of its domain, and if f prime exists at that specific spot, then the function at that spot is going to be equal to 0. That should probably read f prime. I think I typed it in wrong. Let me just double check these. Yeah, that needs to be f prime of c. Okay, so in other words, where the derivative equals 0, whoa, that's nasty. Where the derivative equals 0, that's where we're going to have these max or min values. So where the derivative is equal to 0, that's where we're going to be really interested. Okay, critical points can occur on the interior of a domain of a function at which f prime equals 0 or f prime does not exist. So sometimes you're taking a derivative and you start doing stuff with it, and maybe it becomes undefined because you have, when you get done with all of your work, you end up with something like 1 over x squared. Okay, you can't have 0 in the denominator. So if this was our derivative, if f prime of x was equal to this, say, just for example, then we would have a critical point when x equals 0. That's a critical point because we're undefined at that spot. If we had something set up where we maybe had, like, say, f prime of x equals like x plus 7 over the square root of x minus 8 or something like that. Well, we're undefined when x equals -8, so that's a critical point. And we're also undefined when x equals -7 because that is a 0. So what we're going to start doing is we're going to take derivative, we're going to set derivative equal to 0 and find the points where either that doesn't exist or it's true. And that's going to give us these local extreme values.